Okay, let's think about this case. When you have r equals to 4 times sine 2 theta, if you try to change this into rectangular, again, it looks very weird because you can replace, well, first of all, if you want to change this into rectangular coordinate system, you need to use this formula, sine 2 theta equals to 2 cosine theta sine theta. And that means you have r is square root of, well, let's first just write down r. R is equals to 4 times 2 times cosine theta sine theta. But individually, cosine theta is x over r, and sine theta is y over r, right? So you can rewrite this as r equals to 8 times x over r times y over r. And now you can multiply this over here. You get r cubed equals to 8 times x of y. And this r cubed, well, r is this guy, right? So you can rewrite it as x squared plus y squared cubed equals to 8xy. And again, you get something very cryptic, right? So you could change this equation into rectangular, but the rectangular coordinate equation is, I would say, harder than this one. But nonetheless, you can go to graphing apps like Desmos Graphing Calculator. There's an online calculator. You can type this in and look at the graph. It'll give you the same thing that I'm going to draw. Okay. There's also a polar mode as well. So you can type this in, and you can get the same graph. All right. So let's try to do this. Now we will need the values of sine. So let's first think about the graph of the sine. The graph of sine goes like that, where this is 2 pi, so this sine theta, pi over 2, 3 pi over 2. But then if theta goes from 0 to 2 pi, you're doubling it, so you will end up doing sine of 4 pi, so we'll need more graph from here. So we'll need this much, which is, this will be 3 pi, 5 pi over 2, and 7 pi over 2. Okay, so for these places, r goes like 0, 1, 0, negative 1, 0, 1, 0, negative 1, then 0, okay? So in order to make use of those values, let's make the thetas go from, well, so here's something that we have to think about. For 2 theta to equals to pi over 2, what's that? That requires theta to be pi over 4, right? And we have to divide this by another 2. And same thing over here. For theta to be 2 theta to be pi, you need theta to be pi over 2. For 2 theta to be 3 pi over 2, you have to divide both sides, so you need theta to be 3 pi over 4. And if you look at these numbers, they're increasing by pi over 4, right? 0, 1/4, 1/2, 3/4. That's increment by pi over 4, right? So that's what we're going to do. We're going to draw this with 0, pi over 4, pi over 2, 3 pi over 4, and then pi, and then 1/4 plus 1 is 5/4, right? So 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. All right, so theta goes full circle, and I've chosen these numbers because that allows us to easily calculate the values of r, right? So I know that r starts from 0, and when theta is pi over 4, that's sine pi over 2. Sine pi over 2 is 1. 1 times 4 is 4, right? So when the sine value go like 0, 1, 0, negative 1, 0, 1, 0, negative 1, because of the 4 multiplied, I'm going to get 4, 0, negative 4, 0, positive 4, 0, negative 4, 0, and then positive 4. No, sorry. Got it backwards. It's all wrong. I was thinking cosine. So, yeah. So you get 0, 4, 0, negative 4, 0, 4, 0, negative 4, and then 0. So that's what you get. All right, so let's try to draw the picture from it. So initially, when angle theta is in the direction 0, 0 degrees is this direction, you're at the origin. What's pi over 4 in degrees? Pi over 4 in degrees is 45 degrees. So 45 degrees is this, right? That's 45 degrees. And for that, you have length of 4. So that's where you are. Okay. And then at 90 degrees, what's the value? You get 0. So you start from here, 0, and then you get to 1, and then you come back to 0 at 90 degrees. Now what this means is that from 0 to 45 degrees, the value of r is increasing. So I mean, to do justice to this, you might want to do pi over 4 in between. Pi over 8. Pi over 8 will give you, what, 2 radical 2, which is like, what, 2.8, something like that, which is like 22.2, you get something close to 3. So you can do more of these points, but that's too time consuming, so I'm going to skip that. Instead, what I'm going to say is that from theta angle 0, as you sweep from 0 until 45 degrees, the radius is increasing, right? The r value is increasing, right? So you start from this point, and it keeps increasing as you go up. Okay. And it reaches 4, which is the maximal possible value for the value of r, right? So it's going to reach its peak here, but as you increase afterwards, now the radius shrinks, right? So the value of r shrinks down, and eventually it's going to come back to 0. And because of the way we are increasing the radius, and you have the r value going up and then down, when it meets 0, it's going to meet 0 with this vertical line 90 degrees, or pi over 2, this pi over 2, being the tangent line to the curve. Is it okay? Does that make sense? Right. So you start from here, reaches the peak, and comes down back to 0. And here, the tangent line when you begin is this horizontal one. Tangent line when you complete at this one loop at 90 degrees is, again, the vertical one. That's the way you should say. Okay. But then, now what happens? As you go to the next 3 pi over 4, okay, what's 3 pi over 4 in degrees? 3 times pi over 4 is 45, 45 times 3 is 135. And 3 pi is this direction, right? So wait, the r value is negative. What does that mean? That means you're pointing at this direction, but you go backwards by degree. So you actually go backwards, and you get here. And what's happening is that it keeps, the value of r keeps going negative as the ray sweeps from 90 degrees to 135 degrees. So as it sweeps this way, the actual graph is being plotted behind me that way. Okay? And it goes to the peak negative value, which is -4 at 135 degrees. So what happens is that, again, this vertical line is a tangent thing, tangent to the curve, keeps going negative and reaches peak negative at 135 degrees. And then afterwards, it turns back because the absolute value of R goes down towards 0. So it turns back and hits 0 when you have 180 degrees. Pi is like this way. So you keep doing this, and then you see that, oh, so it's like that. And then as it sweeps from here to there, now it's positive again, so does this. Okay, from 0, angle pi to 5 pi over 4, which is 225 degrees. That's 225 degrees, right? It reaches the peak, and now it comes back and does another loop here and completes it. Okay. So that's one full loop. When you reach 2 pi, it comes back to 0. So you have all of these horizontal and vertical axes being tangent to that curve. So you get a beautiful, some like flowery thing that's 4 petals. Okay. So the obvious name for this that people have named, this is called a rose with 4 petals. That's the official name for this curve.